functions and how to identify a function. So before we get started, I'm going to sum up the whole page of notes in just one simple statement that x cannot repeat. Okay, we are going to get more in depth in this in the notes, but that's the main takeaway, is that x cannot repeat if it is a function. If x repeats, it's not a function. So let's talk about this a little bit more. A function is a relation in which each element of the input has a single output. So the input is a value substituted for an x value, and the output is the result of that value being put in. So x is the input, y is the output. Each x value is only allowed to correspond to one y value. In other words, like we said in the beginning, x cannot repeat and have a different output. So each time you put in an x value, if it's a function, you're only going to get one y value. So there are different ways that we look at relations. One of them is an ordered pair, in a list of ordered pairs in set notation that you can see here. Then we also have a table, a mapping diagram, or a graph. These are all ways that we can represent relations. Now we're going to be looking at relations and saying, is this a function or is it not a function? So for ordered pairs, a table, and mapping, the relation will not be a function if any x value corresponds to more than one different y value. So if you'll look at this first set of ordered pairs, each x value is different. There's no repeating values. So this is a function. Now if we look at this second set of ordered pairs, we see that -1 gives us 7, and then -1 gives us -2. So that's a single input, but gives you two different outputs. So this is not a function because we see that x repeats. So you're going to be looking for x repeating when you're looking at an ordered pair, a table, or a mapping diagram. For a graph, we will just simply use the vertical line test. The relation will not be a function if the line ever passes through more than one point. So I'm going to draw vertical lines. If it passes the graph more than once, anywhere, then it is not a function. So let's look at the function on the left. It's just a diagonal line. So I am going to just draw some vertical lines, and I should be able to draw this vertical line anywhere, and it's only going to cross the graph one time. So you can see each vertical line is only passing that graph once. So this is a function. Now, if I draw vertical lines on the second graph, the circle, how many times is my vertical line going to pass through that graph? Well, that's going to pass 2 times. I could maybe draw a line here, and it only passes 1 time. But you have to be able to draw a vertical line anywhere, and it does not pass the graph more than once. So because it passes more than once, this is not a function. So in other words, it fails the vertical line test, so it is not a function. So this is a pass the test, and this is a fail of the test. So let's go through some examples. Okay, number 1 is a set of ordered pairs, and I'm going to be looking for the x values and see if any of them repeat. So I have -1, 3, 0, and 2. None of those are the same, so yes, it is a function. It's going to say to state why. Well, the reason is x does not repeat. Let's look at number 2. We have 0, 2, 3, and 2. That 2 repeats, and it gives us 2 different numbers. So this one is not a function because x repeats. Okay, so let's look at now a table. Same information, just presented in a different way. I'm going to look at all the x values in number 3, 3, -1, 0, 2, 3. Now let's look at 3. First time it gives me 5 as an output, and the second time it gives me 3 as an output. So this is not a function because x equals 3 repeats. So let's be more specific up here, I guess. X equals 2 repeats. Number 4, we have 1, 2, 3, 4, 5. So x does not repeat. Yes, this is a function. X does not repeat. Now, if I have a table where x repeats, but it has the same output, that is still a function. So let me just draw a little example over here of a table. All right, so if I have, let's see, I'm going to use blue. 2, -1, 0, -1, and 5. We'll say -5. And then my outputs are 6, 2, 3, 2, and 0. You can see that x repeats. I have -1 and -1, but the output is the same. So these are the same points. So I'm not getting a different output with the same input. So this is still a function. So that's the difference. If you do see x repeat, make sure that it gives you a different output before you decide that it is not a function. Okay, moving on to mapping diagrams. This is, again, the same information. These are still points, just more shown as input-output. So you can see that -1 results in a 2, 0 results in a 1, 1 results in 2, and 2 results in a 5. So because, again, we don't have the same number repeating, giving you a different result, this is a function. Now let's look at number 6. -4 would give me 4. -1 gives me -1, and -1 gives me 7. So I don't even have to go any farther than that to see that if I put in -1, I'm getting 2 different outputs. That means that x is repeating, so it is not a function. Okay, and let's try the vertical line test with these last 2 examples because they are graphs. If a vertical line passes more than once, then it's not a function. So I should be able to draw a vertical line anywhere and it not pass the graph more than once. Well, I can draw a line there, and both times it's going to pass twice. So this is a fail, so it is not a function. Does not pass the vertical line test. Now let's look at number 8. I can draw a vertical line anywhere, and it's only going to cross the graph once. So here, and here, and here. Any vertical line I draw is only going to pass that graph one time. So yes, it is a function. It passes the vertical line test. So that's all you're going to be doing on today's practice, is deciding, is this relation a function, using these rules. I promised a student I would say hello to him in one of my videos, so hi, Kyle. All right, get on to your practice now.